some sample problems here showing you how I did those. You have homework that you're going to be able to work on in class on Friday when I'm absent, and I want to do a couple examples. So sample 1, Batman of mass 80 kilograms accelerates upward at 3 meters per second squared due to the thrust in his jetpack. Ignoring air resistance, draw a free body diagram and determine the amount of thrust. So the free body diagram looks like this. We know the thrust has to be greater than the gravitational pull, and I put that as force mg because that's how we would calculate it, as mass times 9.8 newtons per kilogram. It has to be greater because Batman's accelerating upward. So to calculate the amount of thrust, I want to start with Newton's second law. So like I said, that's really the master law of all physics. F net equals mass times acceleration. So now I need to think about the two forces which I had up here, thrust and gravity, and recognize that if those are acting in opposite directions, I would subtract one from the other. So the thrust minus the gravitational force would equal the mass times my acceleration upward. So now I'm ending up putting this in variables. So essentially we've got the thrust minus mass times 9.8 is equal to mass times 3. So thrust minus 784 equals 240. That gives me a total of 1,024 newtons. And yay, upward thrust should be greater than the pull of gravity because the person's actually accelerating upward. Sample 2, Tarzan, mass 100 kilograms, is holding onto two vines at the angles as shown. Find the tension in each vine. So the first thing I do is recognize we need to get his weight. That's 980 newtons down, m times g. And that weight is going to basically be split up among these two vines. His weight is down, so vertically, both those vines will need to hold the equivalent of his weight. Not each, but together. So the upward vertical components have to equal the gravitational pull downward. So algebraically, I'm going to write that. T1 vertical plus T2 vertical equals weight. So I could say T1, tension 1 sine 60 degrees plus tension 2 sine 60 is equal to 980 newtons. But since T1 and 2 are at the same angle, we'll have the same tension. If it wasn't true, you may have to do a substitution of one variable into another, but we don't have to do that this time. So this time we can say T1 equals T2 equals T. So essentially T sine 60 plus T sine 60, or 2T times 60 degrees, is equal to 980 newtons. That gives me a tension of 566 newtons in each vine. Again, if these weren't equal to each other, weren't equal angles, I could recognize that the horizontal component of vine 2 rightward would have to equal the magnitude of the horizontal component of vine 1, no matter what, because there's nothing else acting horizontally. Moving on, for the forces sample problems number 3, we've got something here. A student is dragging a bag of leaves based on the free body diagram shown. So force applied is 60 newtons, normal force 60.5, gravitational force 60.5, friction of 22 newtons. So determine the net force. So there's no vertical net force because it's the same amount up and down. So horizontally, I would take 60 minus 22, and that's 38 newtons to the right. If I want to find the acceleration of the bag of leaves, it's F net over m total, 38 newtons. How do I get that mass? Well, if weight is equal to mass times gravitational acceleration, then mass equals weight divided by gravitational acceleration. So that's 60.5 newtons divided by 9.8 kilograms. That's 6.17 kilograms. So I needed this, but I didn't have it directly, and that's why I solved for it in the green up here. So I have 38 newtons divided by 6.17 kilograms, and have an acceleration of 6.16 meters per second squared to the right. To find the coefficient of friction, which I said I'd do, and apparently I didn't, I would take 22 newtons, which is the frictional force, divided by the normal force of 60.5 newtons. So that's going to give me somewhere around 0.3, 0.36, something like that. The last one, or the last sample, let's assume Spencer and Marissa are part of the stage crew for theater. They must quickly move, I had a typo there, they must quickly move the 150 kilogram, 8 kilogram baby grand piano off stage by applying a force of 550 newtons on the piano. Assuming it accelerates at 1.1 meters per second squared, find the force of friction on the piano and the coefficient of friction. So I'm going to do a free body diagram first. So the vertical forces are balanced. That's going to help us come up with a mathematical model. But the horizontal forces cause acceleration. I've got a dotted line around those. So the applied force minus friction will give us the acceleration. And we're assuming g is 9.8 newtons per kilogram. So think about that. If acceleration is net force over mass, I can say that would be the applied force minus the friction force divided by mass. So I know the acceleration. I'm going to rearrange this to get applied minus friction equals mass times acceleration. 550 minus friction equals the mass times the acceleration. That gives me a frictional force of around 174 newtons. Oops, no it doesn't. 550 minus force of friction is 174 newtons. So friction ends up being 376.2 newtons. To find the coefficient of friction, I take the force of friction over the normal force. Well, how do I get the normal force in a level surface? Going back to this diagram, I know that that would be the floor, and it's the same size as the force of the earth. So, thinking about that, I can take the weight of the object and have that set equal to the normal force. So m times g, 158 kilograms times 9.8 newtons per kilogram, that's 1,550 newtons. 376 newtons of friction divided by 1,550 newtons of normal force gives me a coefficient of friction of 0.24. So I went through those quite fast. Take a moment, look through the video again, pause it. I think that hopefully will help.